Recording in progress.
Hello everyone, welcome. Can you hear me?
Hi, I can hear you.
Okay. So now we'll start our today's session. I simply share my screen. Can you see my screen?
Yes, I can see it.
Okay. So hi and welcome to the second day's training session on beginners course on Google Earth Engine, and I am course coordinator. And today basically this is our second day, and today I will try to discuss about this topic. First of all, I will try to discuss the filtering and visualizing the satellite images in Google Earth Engine platform. So basically in this case I will try to discuss mainly Landsat and Sentinel imagery. So how you can easily filtering your Landsat and Sentinel image for a specific region and a specific time frame or specific properties, how you can easily filter it. So I will discuss a lot of things in here. Then I will focus the how to export this satellite imagery from the Google Earth Engine platform. Then analysis of the NDVI value, making a time series chart. So in this part we also try to make a time series chart. Mainly in this time here I use the NDVI time series chart for a specific time period on a specific region. Okay. Then I also focus here the NDWI calculated from the MODIS as well as Landsat data. Okay. Then how to export the TIP images, we also discuss about this topic. Then how to export any shapefile from Google Earth Engine platform. Okay. So basically this is our second day's course content, and we also cover all of these things today. So after starting our today's session, first of all I will try to discuss about our rest of the part. So okay. So after starting our today's session, first of all I will try to discuss the rest of the part of the previous day classes. So for the reprojected the scale value, so I will simply go to my code editor. After completing this part, then I will start our today's session. So this part, so mainly yesterday's session I will try to discuss about the how you can easily import the MODIS NDVI Terra vegetation indices for 60-day global 250 meter resolution, this dataset, how you can easily import, then filter and reduce, all of the things we will explain. Okay. So now it has a problem. We already know that NDVI value, this range between -1 to +1 always stay this range, but in this time when I simply click to here from this on a map, I can get this result like this. You can see it more than 5125, but this result will be sequence, this range will be -1 to +1, but in this time it show like this. So that's why in this time we need to reproject our scale value. Okay. So for this we can simply go to our information sheet, image information sheet. Here you can simply click on the bands, and here you can see this band has the mean and max value, will be defined their mean and max value for NDVI, and also they defined here the scale factor. Here you can say that is the scale is the 0.0001. so this is the scale factor. So in this time you just multiply this scale factor with your whole collection, then it will be converted your range between -1 to +1. Okay, so now in this time I want to reproject it, so that's why I simply multiply this value with my whole collection. Okay, this is our scale factor. Just we multiply it, then it will be automatically reprojected. Okay, and then we can get our result between -1 to +1. So now we will do this. So simply, first of all, you can see in this time I can simply print this is our filtered NDVI, and I want to check how many images will be available here. So I simply use here the size function and then simply click to the run. So here you can get total 138 images, and this image is not reprojected of your scale value. Okay, so now first of all, this is our whole collection. Okay, 138 images, this is our whole collection between this time period, and first of all I need to reproject this whole collection. Okay, I need to reproject it the whole collection. So that's why I simply multiply with this whole collection with my scale factor. So in this time here you can see my scale factor is that 0.001. Okay, just I multiply it, then I can get the reprojected images. Okay, so first of all, for this I take a variable. I simply take a variable and I can give this variable name is that scaled NDVI. You can use any variable name, it's totally depend on you. So in this time I want to reproject it. So I want to reproject it the total 138 images. Okay, and this image will be stored in a variable. This variable called filter NDVI. Okay, so just I simply copy this variable name filter NDVI and paste here. Okay, just it. And after I make a function, this function multiply with our scale factor the whole collection. Okay, so I simply use a function, this function called the map function, and in here why I can use this map function I explain later. So first of all I make the function, and previous day classes I discussed about the function. When you want to make a function, create this function using the JavaScript language, you can just put a function keyword. Okay, I just simply put a function keyword. After this I use here the parenthesis. I simply use here the parenthesis, first parenthesis. Then I put here the element name as a variable. Suppose in this time I simply use the element name is the img. Okay, after this I simply use here the curly bracket, and between this curly bracket I just put my argument what I need. So in this time I want to multiply my scale factor with the whole collection. Okay, so I simply use the return function, and I return from here my image. This is my element name. It will be multiplied with my scale factor 0.0001. Okay, so here you can see I make a function. In this line you can see I make a function, and in this function I simply take a element name image, then I simply use the return function, then image multiply with my scale factor, and now I want to connect it. This function with my whole collection. My whole collection variable name is that filter NDVI, so that's why I simply use the filter NDVI. So now I make a function in here, in this line code I make a function, you can see, and now I want to connect this function with my whole collection is the filter NDVI. So this connecting work will be taken by this map function. So mainly this map, this is the function, and this function mainly connect my function. This is my function which I created, and this is my whole collection which included total 138 images. So I make a function, and now I want to connect it with my whole collection. Okay, so that's why I simply use here the map function. Okay, and then I simply use here the copy properties. and in here I just simply use my element name image, and then it will be start from my system time start and system time end, because here I already defined a system time start and system time end. So that's why I simply define here the system time end, sorry, system time start, then system time end. Okay, so here you can see I just make a function. This is my function, which function I take a element name img image, then I return this function, this image multiply with this scale factor, which scale factor I can get from here this information sheet. Then I simply use the copy properties, then image, here I use the system is time start. It means that this is a system has already a start date and end date, so I want to get this result between this time period. Okay, so I simply define the system time start and system time end. It means that it had the system, is this system has a time will be start from the 1st January year of 2050, and this system the end system date in the 2020 December 31. Okay, so I define it, and I create this function, and now I want to connecting this function with my whole collection. Which whole collection? This is the filter NDVI, and it has included the total 138 images. Okay, so now it will be reprojected, and now I want to check how many images will be available here. I simply use here the print function, then simply use here the scaled NDVI, and use here the size function. Okay, then click to the run. So now you can get the same result of the images 138, but first of all this 138, this is not reprojected our scale value, and then when I can get the scale value, I can simply store this reprojected scale NDVI, this variable included. I can get the same images 138, but in this time this images is reprojected. Okay, and now I want to use this, suppose in this time I want to calculate the mean NDVI. So I simply, you can see already we calculated the mean NDVI, but previous we use here the filter NDVI, and this filter NDVI included also 138 certain images, but this image is not reprojected scale factor. So I simply make a function and reprojected it, and 138 images will be stored under this variable scale NDVI. So from this scale NDVI I can get 138 images, and this images is the reprojected our scale value. So I simply copy this reprojected scale value and paste here. Okay, and everything is the same. So I simply click to the run. You can see we can totally get a white map. Okay, we can see there is we can get totally a white map, because you can see here our visualization parameter here I defined the mean pixel value will be start from the 0 and max pixel value up to 8000 between this range, but we can convert it our -1 to +1. So that's why this I simply change it. Suppose in this time I want to hit the -1 and my max value will be +1 between this range. I simply click to the run. So now I can get this result. Okay, so now you want to check from here. Suppose I am simply click on the any portion of the map, we can get this result, our range between the -1 to +1, we can get this result 0.18. Okay, so now this map is the reprojected. So any question in this time in here? Anyone? For this function, any question or any doubt? Anyone, any question or any doubt?
I think you can proceed.
Okay. So this is the mainly for reprojected, And if you want, you can also export this image as a TIFF format and work with the other software, just ArcMap or QGIS software. You can also do it. So for this I simply use here the export dot image to drive, this function, and I simply press on my keyboard Control and backspace together. I can get all of the information. I want to make a dictionary. I simply use here the curly bracket between two sides. And after this, first of all, image. So this is the value. You can just put here which object you want to show on your map. So in this time I want to show here the study area, so I simply copy this study area and paste here. Then description can be anything, it's just a name of your file. So I simply put this description. This is the NDVI for Dhaka city. Okay, just simply put this name. And then folder. So folder, this is the specific folder. So we can simply use here this folder, which name you want to put here. This name will be automatically generated in your Google Drive and make a folder. I simply put here this folder is the 10 page. Okay. So file name prefix not needed for this time. I simply remove. Dimension are needed. Region is needed. Region is your shapefile variable name. So what is our shapefile variable name? You can see this is the ROI. I simply put here the ROI. And scale is the resolution of your satellite images. So in this time here I use the MODIS and NDVI. So this resolution you can see 250 meter resolution. I simply use here the 250 meter in the scale. And CR is not needed, and I do not need this for this. I simply remove all of these things. Okay. Then I simply click on the run. You can see our task tab will be running. I simply click on the task tab and then simply click to the run. Then everything is okay. I just simply click to the run. It will be stored in my Google Drive. After this I simply download this and I simply import this in my ArcMap software or QGIS software, then make the map layout. Okay. So this is the mainly for the exporting. When you want to export any TIFF image, we can use this function, export image to drive. But it has some problem when you work with the big region. So then we need to also use here the max pixel function. So we also try to show you the next time when you work with this the big region. Okay. So I hope in this time it will be, you can easily understand. You can see it already downloaded. So you can simply, you can simply go to your Google Drive. So I try to show you that. So simply go to the Google Drive. And here I already created a folder. This folder is the 10 base. Find this folder. You can see this is a 10 base. This folder I created. So I simply click to here. You can get this TIFF images. I simply download it. Then it will download it. I can simply open it my ArcMap software, and after this I make the map layout and everything for my research paper or presentation work. I can easily make it for the produce this map. Okay. So I hope you understand in this part. So if you have no question, then I can go to my next slide. Any question in this time? Anyone?
This exporting, the available options is only Google Drive, or you can save it directly into your Windows.
Okay, so this is the another option for when you want to make the link. Suppose you want to generate a link. So when you can simply click on this link, this file will be automatically downloaded. But Google Earth Engine has some limitation. You cannot generate this link up to 30 megabyte. Okay, and I also try to show you that how you can make the generate this link in today's session. I also try to show you that. So it will be, you cannot download the more than 30 megabyte. Okay, so we can, when work with the shapefile, exporting shapefile, then we also try to show you that how you can easily generate the link, and anyone when click this link, then it will be automatically downloaded from this link, and anyone can access this link for downloading this specific shape file. Okay, any question? Okay, so now I go to my next slide. So now first of all I will try to discuss about the filtering and visualizing the satellite images in Google Earth Engine platform, and it is one of the most fundamental part of Google Earth Engine is selecting and filtering the image you need and display this image on the map. So Google has already selected a wide variety of public dataset will be available here, and we already discussed about the public dataset. So in this public dataset you can get all of the satellite images, MODIS, Sentinel and other satellite images you can easily access from this public data catalog of Google Earth Engine. So you can also search in the search bar of the top of the code editor for searching the Google Earth Engine dataset. Okay, so mainly when you want to filter any satellite images, it depends on some factor. Suppose you want to filter these satellite images for a specific region. Suppose you want to need a satellite images for the region of Dhaka city, okay, or other region what you need. Okay, so you can filter these satellite images for a specific region, or then suppose in this time I want to show you that suppose you want to need a picture satellite images for the region of Dhaka city. Okay, so this is the one factor for region or your region of interest. Okay, then we can also filter these satellite images. Suppose I want to filter using the different types of properties, image properties, I can also filter it. Suppose I want to need only for those images which image will not be more than 1% cloud cover. Okay, so this is the one factor for filtering the satellite images. So filter metadata. Okay, and suppose you need only for this image for a specific time frame or a specific time period you want to need. Suppose I want to need for this the image for the year of 2017. Okay, so this is the another factor. So mainly we can filter our satellite images for a specific region, a specific image properties and a specific time period. Okay, so now I will go to my code editor and practically show you that all of the things one by one, so that you can easily understand how you can easily filter your satellite images. Okay, so I will go to my slide. So I open a new code editor. So first of all I import my dataset. Suppose first of all I want to work with the Landsat 8 collection. So I simply search at the Landsat. Okay, so I simply go to my dataset catalog and I work with the Landsat. I simply click on the Landsat. So this is our Landsat collection. Suppose in this time I want to work with this dataset for top of atmospheric Landsat 8 top of atmospheric. I simply click here. I want to work with this dataset, top of atmospheric dataset. So here you can get all of the information about this dataset. So here you can see this dataset will be available, dataset availability date, it is from the year of 2013 to present time it will be available. And also you can see this dataset provider is the USGS and Google. And also you can see the collection snippet. Previous day we also try to show you that you can just simply copy it and paste in your code editor, then give a variable name, then it will be stored in your code editor. Okay, and you can also see here the bands, different types of the band with the resolution. Okay, so first of all I want to import this dataset in my code editor. I just simply copy this collection snippet and paste in my code editor, and then I give a variable name. Suppose in this time I can give this variable name is for L8. Okay, so now it will be stored under this variable L8. So my whole collection, Landsat top of atmospheric whole collection, will be stored under this variable L8. So now I want to convert it as the import. Okay, so you can also convert it. So I can simply click to the convert. You can see it will be look like a when you import, look like this. Okay, I can simply click to here. You can see now it will be importing. So suppose when I click to the search bar and click on the import, then I can get this result like this. So if you want, you can also copy this collection snippet and paste here, and simply your cursor will be put on in this collection, and then click to the convert. Then it will be automatically converted like this. Okay, so now I will import my image collection in here, and here you can see my variable name is L8. So now my whole collection will be stored under this variable. Okay, so first of all I want to check how many satellite images will be available for the whole world between this time frame year of 2013 to present time. Okay, between this time frame, how many images will be available here? I want to check it. So you already know that how you can check it. I simply use here the print function, and then I simply call my whole collection. So in this time my whole collection is stored a variable. This variable name is the L8. I simply use here the L8, then simply use here the size function. Okay, so size function determine how many images will be available here. So I simply click on the run. So now it will be showing that how many images will be available for the whole world between this time frame year of 2013 to present time. So it will be computing. And we can get here the large collection. Okay, so it will be computing. So here you can see the total collection more than 1 million. So the entire Landsat dataset is too clearly too large work with it. So now we have to filter it somehow. Okay, so now I want to filter this collection. I can filter this collection for my specific region. Okay, so this is my one factor. I already discussed about this. So first of all, suppose I want to need the satellite images for my region of interest is Dhaka city. I need these images only for this region. So first of all, I simply import my region of interest. And we already know that how you can easily import your shape file. Suppose I want to work with the Dhaka city. This is my shape file. I simply click on import. For imported this shape file, you can see it will be showing the table. This is the default variable name. Suppose I change this name and put this name is the region. You can use any variable name. And now I want to intersecting with my whole collection with my region of interest Dhaka city. Okay, so for this I take a variable. Suppose I take a variable and give this variable name is that filter region. You can use any variable name. I simply use here the filter region. Okay, and first of all I call my whole collection. This whole collection included total more than 1 million images will be available here. But in this time I want to need only for those images which image only spread in my region of interest Dhaka city. Okay, so this is my area. I want to need only for those images which image will be cover my area of interest. Okay, so that's why I simply call my whole collection L8. This is my whole collection variable name. I simply use here a function. This function called the filter bounds, and this filter bounds you can see it's intersecting with the geometry with your whole collection. in this time my whole collection is the L8. Okay, this is the L8 for whole collection for Lancet 8 image collection, and now I want to get only for those images which image will be available in my area, okay, or which image will be covered in my area. So that's why in this time I put here the filter bounds function. This filter bounds function whole collection by intersecting with your geometry. So in this time my geometry is variable name, you can see this is my shapefile variable name, it is the region. I just put here the region. Okay, so now I can get here my, so I want to check how many images will be available for my own region of Dhaka city. I simply use here the print function and then simply copy this filter region, this variable, and then I simply use here the size function. Okay, and then click to the run. So now I can get how many images will be available here in my Dhaka city. You can see it's the 354 images will be available here. Okay, but this 354 image has a different type of cloud cover. Okay, it can be 1%, 2%, 5%, 10%, I don't know. Okay, so in this time from the 354 satellite images, I want to need only for those images which image will not be more than 1% cloud cover. Okay, so I need only for those images which image will not be more than 1% cloud cover. So in this time I want to filter my image properties. Okay, I want to filter image properties like this. I want to only for those images which image will not be more than 1% cloud cover. Okay, so first of all I take a variable. Okay, I take a variable and I can give this variable name is the filter. Okay, so something technical issue in my keyboard. Wait a minute, I take another code editor. I simply copy this code and paste here. After this I simply copy and paste, and after this I simply convert it as import. Okay, so now good. So now we can see I simply click to the run. I can get only for the 354 images which image will be available for my region of interest Dhaka city, but in this time I want to only for those images which image will not be more than 1% cloud cover. So that's why I simply take a variable. Suppose this variable name is the filter metadata. You can use any variable name. I simply use the filter metadata, and here you can see this filter region included their total 354 images, and this image, this is the total image, but in this time I want to need only for those images which image will not be more than 1% cloud cover. Okay, so I simply call this variable filter region because it stored the total 354 images. Then I simply use here the filter metadata function. Okay, filter metadata, I simply use here the filter metadata. Okay, you can see this, it has the 3 argument, and first argument is the name, second argument is the operator, and third argument is the value. So name is the image properties name. I can get this image properties from my image collection sheet. Here you can see image properties. So in this time I want to get this image properties for the cloud cover. Okay, I want to need only for those images whose image will not be more than 1% cloud cover. So I simply copy this cloud cover properties, and this is the string. So I simply use here the single quote or double quote between two sides, then paste here. Then operator, I just simply put here the less than, then value less than 1. Okay, so now this filter metadata, this variable is stored only for those images which image will not be more than 1% cloud cover. Okay, so now I want to check how many images will be available here. So I simply use here the print function, then call the filter metadata variable and paste here, and then simply use here the size function, and then simply click on the run. So now you can get here only for the 47 images will be available in here, which image will not be 1% cloud cover. We can get these images, total images 47, and here you can see I filter it. Okay, so after end of this session, less than 1 minute, I will send you the Zoom link again, so please join. So here you can see I can get here the total 47 image, and this 47 image stayed in my Dhaka city boundary, and this image has the 1% cloud cover. Okay, I increase this value, suppose I use the 5%, and then click to the run. You can see this image size will also increase, 81% will be available here. Okay, so in this time I want work with the 1% cloud cover, so that's why I simply use the 1. Okay, so you can see here I filtered these images for a specific region, specific image properties, and this 47 image, it will be for the year of 2013 to present time. You can see it will be available for the year of 2013 to present time, but I want to only for the images for the year of 2017 or any specific time period. Okay,